Okay. All right, so here are two more example problems with slightly more difficult numbers. All right, and then after this, you're going to do 4 more yourself, okay? And again, I'm going to remind you, please, I'm begging you, make sure you actually understand how to do this, because if you don't, you are going to sink really, really quick, okay? Because this is pretty much the hardest stuff. Wow, we probably would have done a little bit harder stuff if we were in class, but this is the hardest stuff that we're going to do of the whole year, okay? So you need to know how to do it, and it's going to be extra challenging not being together, but, you know, it is what it is. All right, so octane burns in oxygen to produce carbon dioxide and water, okay? In this practice, I've given you the equation, and I've already balanced it for you, okay? So you don't have to worry about that. You're just going to worry about the BCA table, okay? How many moles of oxygen gas would be needed? That's this one. To completely burn 4 moles of octane. This is octane. See how it's C8? That means that's octane, okay? And then how many moles of carbon dioxide and water are formed, all right? So the good thing about the BCA table is you just complete all of the calculations at one time, right? And then you just kind of pick out what you want, all right? Okay, so let's go ahead and look at this. So remember, this is the recipe. 2 octanes, 25 oxygens make 16 carbon dioxides and 18 waters. Okay, thank God you don't have to draw that. All right, so let's go ahead and see what we start. So before, that's the B, I have 4 moles of octane. So that's the given. So that one's going to go here. Okay, I don't know how much of this I'm starting with. Okay, but I do know that this is going to be 0. Okay, and again, if you don't want to write moles as you get better at it, it's totally fine. Just put the numbers. It's super quick. All right. Okay, so the octane is sort of determining everything that happens in this reaction. So that's what's going to get totally used up. So that's going to leave me with no octane left over. I want to completely burn the octane. Okay. All right. So now how much oxygen am I going to need? All right. So since the octane is the given, this is going to be a -4. Okay, this is going to be a +4. This is going to be a +4. Right? Remember, the reactants are minus because they're getting used up. The products get a plus because I'm adding product by the end of the reaction. Okay? And then I'm going to put these ratios. All right? Okay, so for the ratio, since this is -4 moles of octane, remember, octane is what needs to go on the bottom. The given is what goes on the bottom. So in the recipe, right, I have 2 octanes. So 2 is going to go on the bottom. All right, and then what I want is going to go on the top. Okay, so 25 goes there, 16 goes there, 18 goes there. Okay. All right, so then I'm just going to go ahead and calculate it. So here I have -4 times 25 divided by 2, so that's going to be 50, right? So remember, for reactants, it goes up here because this is what I have to start with, okay? Because I'm always going to get a 0 down here because the reactant has been used up. Okay, the product starts with nothing, and then I had 4 moles of octane times this ratio, 16/2, which is 8, is going to give me 32 moles of carbon dioxide. And then for the water, I've added 4 moles of octane times the ratio, 18/2, which is 9, which is going to give me 36 moles of water. Okay? And you always just kind of want to do a little check to see if it makes sense, right? I have the smallest amount of octane. Everything else requires quite a bit more, right? So again, this one was easy because basically I'm just doubling everything, right? So instead of 2, I wanted 4. I want to use purple. Okay, so instead of 2, I wanted 4, which is a doubling. See, 25 has doubled to 50. 16 has doubled to 32. 18 has doubled to 36. Okay, right? So this one's a little bit simple still on the numbers. And it's going to get harder, so don't be like, why do we have to do all this work when I could have just written the answer? But I hear you. Okay, all right, what type of reaction is this? This is a combustion reaction. We're just going to try to keep going with that. Remember, a hydrocarbon burns in oxygen to make carbon dioxide and water. Okay, and the word equation is the actual numbers, again, not the recipe anymore. Okay, so I'm going to say 4 moles of octane combine with 50 moles of oxygen to form 32 moles of carbon dioxide. Okay, and these you need to know. Some of you guys are still messing up these names. Come on, carbon dioxide and 36 moles of water. Not hydrogen, oxygen. No, it's just called water, y'all. Okay, water. All right. Okay, let's try the second one. Okay, sodium metal reacts in aqueous hydrogen chloride, okay, or hydrochloric acid, to make hydrogen gas and aqueous sodium chloride. All right. So if you want to, you could add these symbols in here. And probably gas, right? Okay, but you know, you don't have to. Overachiever. Okay. All right. Now, if I start with 0.8 moles of sodium and excess hydrogen chloride, how many moles of HCl will react? Okay, because I have plenty to go. And how many moles of hydrogen gas and sodium chloride are formed? Okay, so we're basically just going to solve the whole thing. Okay. All right, so my given now is going to be sodium. So this is going to be 0.8. And this time I'm just going to show you what it looks like if you just kind of leave out all the units. Okay. I have excess hydrogen chloride, but we're actually going to try to find that out. All right. I'm going to start with 0 up here in the before because it's a product. Okay. All right. Only one thing is given, which for a while, that's how it'll be. Only one thing is going to be given. So I'm going to use up all of that sodium, okay, to be nothing. Okay. I'm going to carry that given to all the other places. Okay, and then I'm going to put my ratios. Okay, so you figure out what the given is. You carry the given all the way across the change line and then the ratios. Okay, the only tricky thing is remembering what goes where. So the bottom is going to be the given, which is this 2 here. Okay, all right. Then I'm just going to carry down the coefficients from the recipe. So this gets a 2. This gets a 2, this gets a 1, okay, right? Because however much of this I need the same amount of these two because it's 2, 2, 2, all right? So -8 times 2 over 2, which is just 1, okay, means I also need 0.8 moles of this, right? Because this is the same amount, okay? 0.8 times 2 over 2 means I'm going to make this, right? Again, same amount. Okay, 2, 2, 2, 1, right? This means I only needed half as much, right? So see, that's why I have 0.8 times a half, which is going to be 0.4. Okay, if you look at this one, hopefully you recognize this one as a single replacement. Okay, a word equation, again, not the recipe, the actual thing that's the amount. So I have 0.8 moles of sodium react with 0.8 moles of hydrogen chloride, or you could say hydrochloric acid, to form 0.8 moles of sodium chloride. If you want to write aqueous and all that, that's great. Okay, and 0.4 moles of hydrogen. Okay. Right? So this is all about the ratios, right? Same, 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 half. Okay? Which you have same, 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 half. All right? So that's all you're doing is you're doing these ratios. Everything is in moles for now. Okay? It's going to get a little bit harder next class. Okay? But so please, please, please make sure you know how to do these. There are 4 more for you to try on your own. Okay, check the answer key, but check it after you do it. Okay, if you just copy the answer key, especially in these, it's not going to be helpful because do you see how I'm sort of jumping all over the place doing stuff, right? The answer key isn't going to be that helpful to follow. Okay, you need to just use it to check and see. If you cannot figure this out and you are lost, you need to contact me so that I can help you. Okay, because you're going to get really, really lost really quick if you don't get on it. Okay. All right, I got like 4 weeks to go, guys. 4, 5, not long. Okay.